This is going to be a lesson about how to divide decimals with long division. Perhaps only one number has a decimal, or perhaps both numbers have decimals. And if you take a look at example 1, I'm going to give you two different problems, not these, but what's going to happen is you're going to have a whole number on the outside and you're going to have a decimal on the inside. So that's what example 1, A and B, will be showing you how to do. Then down here for example 2, what happens if you have a decimal on the outside and a decimal on the inside? That's what's going to be taken care of there. Example 1, A. High school track is 9.76 meters wide. It is divided into 8 lanes of equal width for track and field events. How wide is each lane? Well, when you go through there and you read about this, you need to pick out the numbers that matter. I would say the 9.76 meters wide is very important. And we're going to take that width and we're going to divide it up into 8 equal lanes. And so it's really this idea of if I take the total amount and I divide it up by whatever is the grouping number, that'll work for us. So it's going to be 9.76 divided by 8. How do we put that into a long division setup? Well, there's your division box. Your dividend will be the total, 9.76. That's what we're dividing up. And the 8 will be your divisor number. So let's kind of make some room here for us. When you look at the outside number, just understand that this example has no decimal on the outside. So it's almost going to be the exact same thing that we've been doing with whole number division. Okay, almost. In fact, I'm still going to cover up the rest of the problem and go, can I make that 8 go into 9? Yes, I can. And you'll see that 1 is indeed less than 8, so that works for us. And then we pull our paper back and I go, whoa, I see a decimal point. Put that straight up, okay? Put a decimal point straight up in the answer. That's what's so important for us to do here. And then we can pull back the paper a little bit more and go, hey, there's a 7, and we drop it, just like we always have. And now we can go, hey, 8 goes into 17 twice. And that gives us 1 left over, which is still less than 8. That's good. And now we'll see that we can drop that 6. Let's make a little bit more room here. 8 goes into 16 2 times. Nothing's left over. So each lane of the track is 1.22 meters wide. Same thing's happening here on example 1, part B. The aerobics classes cost $153.86 for about 14 sessions. What is the fee for one session? Well, 14 has sessions next to it, so I think that's going to be the grouping number. So the total number is going to have to be the total amount that you paid, $153.86. The grouping would be 14, and now we just set up our division problem. Again, the outside number has no decimal, so there's not a lot that we have to do that's different. Sometimes I put the $sign inside the division box since that 153.86 was money. Sometimes I don't, so this time I did. Can we put 14 into 1? Nope. Can I put 14 into 5? Or excuse me, to 15? Sure can. 1's left over, and you'll notice that that leftover amount is less than our divisor of 14 on the outside. So we did that correctly. Now, what about the 3 when we drop it down? 14 can't go into 13, so this is one way that you can handle it. You can just say, well, 14 goes into 13 0 times. What's 0 times 14? 0, and we still have 13 left over. Is 13 less than 14? Yes, it is. What about that decimal there? Pop it straight up. Make sure it's visible too, okay? Now, the 8 can drop down, and now we can say, can 14 go into 138? Yes, it can. It can go in 9 times. 9 times 14 is 126. We've got 12 left over. Pull that paper back. We drop the 6 down. 14 goes into 126. 9 times. Nothing left over. So what's the fee for one session? The fee for one session is $10.99. If you want, you can pause the video and I'll show you the answer to these after you work them out. 1.95 and 0.92. Now we're going to take a look at the division problems where we're going to have a decimal on the outside of the division box. So Ella uses about 0.5 pounds of raspberries in each of her raspberry cakes. How many cakes can Ella make if she's got 3.25 pounds of raspberries to make them with? Okay, well, again, it's this idea of total divided by grouping. The total amount of raspberries she has is 3.25, so I'll put that there. And each one of the cakes that she's going to make would require 0.5 pounds of raspberries, and so that's going to be our grouping number. That's what's going to happen again and again and again. So let's put this into our division box here. 3.25 is total. That goes inside. That's our dividend. 0.5 is our grouping number, so that's our divisor. That goes on the outside. And let's pull that up and take a look at it. Now, there's the mathematical way, and then there's the common sense way of handling this. I want to show you the mathematical way, and then we're just going to stick with common sense. When you have a decimal on the outside, right there, that's an issue. That divisor has a decimal in it. So what do you do mathematically? Well, you times it by a number to move that decimal all the way to the end. I know that I can take basically 0.5 and I can times it by 10 and I would get 5. That's like we moved the decimal down. But wait, whatever you did to the outside number, you have to do to the inside number. What do we do to the inside number? We times, or what do we do with the outside number? We times it by 10. So the inside number, the 3.25, we're going to times that by 10. And I'm going to squeeze this in here. We get 32.5. Okay, that's the mathematical way. Let's go back to the common sense way. Take a look at the outside number, the 0.5. Just move the decimal all the way to the end of the number. Not kind of to the end, all the way to the end. I don't care how many places you have to move, but then just look and see how many times you moved it. In this case, we moved it once to the right. So go do that to the inside number. Move that once to the right. And then you can see what's happening here is that really that 0.5, we made it into a 5, and the 3.25, we made it into 32.5. And now we're back to familiar territory. We have no decimal in the outside number. So let's just use that red problem we've created right there. Can 5 go into 3? Nope. Can 5 go into 32? Yep. That's good. 2 is less than 5. It's supposed to be. What happens when we see the decimal? Well, this is when you just bump it straight up. Pull that paper back a little bit more. We drop down the 5. 5 goes into 25 5 times, and nothing's left over. Okay, so that's what's going to happen here. Anytime that you see an outside decimal, just move it all the way to the end of the number, and then have the inside moved the same amount of times to the right. It creates a new problem for us. And just like always, then you can pop that decimal straight up. Now, let's get back to the problem though. How many cakes can Ella make with 3.25 pounds of raspberries? It says 6.5 is the answer. I don't think she's really wanting to make half a cake. So just take the whole number, 6. Ella can make 6 cakes. If she gets more raspberries, she can make a 7th. But until then, can't make the 7th cake. Here's the last example part right here. Anthony spent $11.52 for some pens at a store that were on sale for about 72 cents each. And there's that keyword each, so that's going to be the grouping number, you know, total divided by grouping. So it's going to be 11.52 divided by 72 cents. Let's go ahead and slip that into the division box for ourselves. This time I'm going to leave the dollar sign out. 72 cents goes on the outside, and I'll leave the dollar sign out there too, because again, sometimes I put it in, sometimes I don't. Now, let's kind of pull this up here and look at it. Let's see, this time the outside number is a decimal again. So I need to slide that all the way to the end. Right there. So that's going to make it like 72, right? But since I messed with the outside, I've got to mess with the inside. And since it went 2 to the right, I've got to take that decimal on the inside and move it 2 to the right. So that's going to make it like 1,152. So let's just rewrite the problem so it's nice and neat for us right there, and then we can go do our division just like always. Don't worry, there's no decimal there, right? So don't worry about it. Can 72 go in? Nope. Nope. Now we can. It can go in once, because if I went twice, it'd be like 144. So 72 times 1 is 72. We're going to have to borrow here in just a second. That 1 minus 7 we can't do, so I'm going to borrow over from the hundreds place, make it a 0, make that 1 into 11, and we get 43. 43 is less than 72. Again, it's important to check that. Now, what happens next? The 2 drops down. How many times can it go in? It actually goes in exactly 6 times. Nothing's left over. So now after all of that work, how many pins did Anthony buy? He bought 16 pins. You can pause the video and I'll show you the answers here. As soon as you're ready, you can hit play.